second half of the pre-test video. I just didn't have time to get it all done in one setting, so this is the second half. Looking at problem 21. Problem 21 is a cone with half a sphere stuck on the end of it. So we'll have to deal with that. So it's a cone and it's got sort of half a sphere down here. They tell us the radius of the sphere is 5 inches. My picture's not very good, but so that's 5 inches. And this slant height of the cone is 13 inches. I don't know that we'll really need this height, but just in case, that's a right angle there. So this shape would be a right triangle, and you should be able to pick up on the fact that that fits into the 5, 12, 13 Pythagorean triple. So the actual height of the cone is 12. Again, this is the slant height. This is the height of the cone. For volume, so what we're going to do on this, or let's do surface area first. For it, we're going to take the cone and then half the sphere, cut the cone and half a sphere, and deal with that. For surface area, we're going to take half the sphere, and I just like to write this out in words sometimes so I remember, plus the surface area of the cone, but on the cone, the base of the cone, the circular part at the bottom of the cone, which you can't really see in my drawing, but if you look at the picture on there, that circle on the bottom of the cone, you're not going to have it as part of your surface area. So we're actually going to do the cone surface area, but we're going to subtract off the base of the cone. The formula for volume of a sphere is 4 times pi times radius squared. It's a r. But we only want half of that, so we're going to divide that by 2 once we get that answer. And for the cone, the formula for the surface area of a cone is pi times radius squared. And there's actually 2 formulas that we could use. I'm going to use the one that deals with the slant height because we already knew the slant height. So it's pi times radius squared plus pi times radius times s. And this time we want to get rid of part of that. Well, the part we want to get rid of, if you'll notice right here, that's a circle, area of a circle. That's the bottom of the cone. So we're just going to get rid of that. And all we're going to do is plug in here. So we got 4 times pi times the radius this time is right here. That's 5 squared. And we're going to divide that by 2 plus, and again, we're not even going to use this part. Then we got pi times 5 times the slant height, which was 13. And what I would do is plug this first part into the calculator, then plug this part into the calculator, then add them together. So grab your calculators, do that. And for this first part here, I got 157.1. That's the sphere part. And then for the cone part, I got 204.2, and we just add those together. And I end up with 361.3, and our units were inches, and we're doing surface area, so it's area, so inches squared. 361.3 inches squared. Now for the volume of that same picture, volume, again, if we write it out in words, for volume, we're going to do the whole cone. We want the volume of the whole cone, plus we only want half a sphere. So volume of half a sphere. And the formula for volume of the whole cone is pi times radius squared times height plus the sphere. The formula is 4/3 times pi times radius to the third, and we only want half that, so we're going to divide that by 2. Now with this second part, don't let that confuse you because you got fractions and fractions, because your calculator is going to do most of this for you. So we'll just do the top part, hit equals, and then we'll end up dividing it by 2. Now here we do need the height of the cone, so it's a good thing we found this. Remember, this is your height, this is your slant height, 2 different things. So we got pi times 5 squared times the height, which is 12, plus 4/3 times pi times 5 to the third power. That means 5 times 5 times 5, and then we're going to actually end up dividing that by 2. So grab your calculators and you can do this part, then do this part over here and divide it by 2. On the first part, I got 942.5. On the second part, when you punch this in, you can just punch in 4 divided by 3. Then probably hit equals. Then hit that times pi. Then times 5. And you can just do times 5 3 times. So times 5 and times 5. So just put in 5 3 times on your calculator, or you can use the little caret on your calculator to do 5 to the third power. The little caret's the same, probably the same button as the pi button or somewhere on there, depending on which calculator you have. Hit equals, and then we want to take that answer and we want to divide it by 2. So I end up with 261.8. Then I add that 261.8 plus the 942.5, and I end up with 1204.3. And this is volume, so our units are going to be inches cubed, or inches to the third power. On the next one, we have a triangular prism. And I've already drawn off. In the triangular prism, you got the 2 bases, which are triangles, and then you got 3 rectangles. So you got the 2 bases that are triangles and 3 rectangles. In the triangles, we need to know this side is 12 and this side is 5, and it's a right triangle. Remember, these 2 triangles are going to be the same, so we really only need to find the area of one and then double that. Formula for area of a triangle is 1/2 times base times height. Well, it doesn't matter in a right triangle. Remember, in a right triangle, the 2 legs are the base and the height, so it's 1/2 times 12 times 5. We do half of 12, that's 6. 6 times 5 is 30, so the area of that triangle is 30, the area of that triangle is 30. Now for the 3 rectangles, we just got to find the length and the width on each one. If I look at the bottom rectangle, it looks like it's 3 by 12. If I look at the side going up and down, the rectangle going up and down, it looks like it's 5 by 3. And then the slanted rectangle and the triangular prism, it looks like it's 3 by 13. And you just multiply those together, that's 36, that's 15, and that's 39. And we're just going to add all those areas up to get the total surface area. 30 plus 30 is 60. 60 plus 36 is 96. 15 plus 39 is 54. And we're going to add those. We get 0 there. 150. So our surface area is 150, and our units are meters squared. So 150 meters squared. Then the volume, for the volume we just find, remember volume for any prism is big B, which is the area of the base, times the height. And our triangular prism, if I can draw this just real quick. In our triangular prism, we have something that looks like that. It's not very drawn very well, but the base, or the bases, are the two triangles. Well, we already found the area of them, that was 30, so that's the big B. And then we're gonna take it times the height. The height is the distance between the two bases, so that's that little part there, which is 3. So the volume is just gonna be 30 times 3, which is 90, and it's meters cubed, because it's volume. On the next one, to find the surface area on the next one, I've separated it off already. We got the 2 L shapes, which are our bases, and then we got 6 other rectangles, and we just have to go through and sort of separate them all, find the area of each one separately. On the L shapes, we got a 6 here, we got a 2 here, and this is a 4. We're gonna have to separate those somehow, so you might just separate them this way. So the area of this part on this side is 12. This one, it's not the 4. We know that this edge out front here is 2. If this part is 2 and this whole distance up here is 4, then that means that part's 2. So that makes that 4. So the area of this whole L is 16. That means the area of this L is 16. And if we look at each shape separately, if we look at the back is 6 tall, and then it goes across, which is 7. 6 times 7 is 42, so that's the area of that. Then if this is our top, the top is 4 by this way is 7, so 4 times 7 is 28. Then we got that little nose part on the front, and it is 2 by 7, which has an area of 14 then. And then the part underneath on the bottom, or on the, sort of the part that's facing down on the bottom of the L is 2 by 7, same as the other one, so it's 14. And then the front sort of face, the bigger front face, is, let's see, that would be, this would be 4, going up and down, and then across to 7, so that's 28. And then the very bottom of the L, the part that looks like it's sitting on the ground, is 2 by 7, that's another 14. And we're gonna add all those up. When I add them all up on my calculator, I get 172, and our units were yards squared, since it's surface area. Now to find the volume of that shape, a couple different ways we could do it. Probably the easiest way, even though this isn't any kind of rectangular prism or triangular prism, this is still a base, and that base still goes back to the other base. And this distance, we could just use it, and we know the area of this base is 16, so this is big B times H. We know the area of that base is 16, and then this would be our height, when the distance from one base to the other, and that distance is 7 this time, so all we really need to do is 16 times 7, and you end up with 112 yards cubed. That's our volume. Now the other way you could have done it, you could have split it off into 2 rectangular prisms. One that's that one, and then the other one that's this one. You could have split it off into those 2 and found the volume of each one of those by doing length times width times height, and then add them up. Either way, it's going to give you the same answer. On 24, we have a swimming pool, an in-ground swimming pool, and they tell us it's 60 feet, probably 60 feet going this way, and it's then 22 feet, that's probably sort of the width of the swimming pool, and then the height right here is, or the depth of the swimming pool is 9 feet. And we're trying to see how much water we're putting in it, and we'll deal with how many gallons here in a minute. So what we're actually doing is finding the volume. Well, the formula for volume is just length times width times height. So we got length times width times height. That's what we're going to use for volume. But they're saying, and you normally would do this, you're only filling the swimming pool up to a level of 8 foot deep. You're not going the whole distance clear to the top, because then your water's all running out and everything. So you're only going up to 8 foot. So our length, we'll go with 60. Go with 60 on the length. The width, we'll go with 22. And the height is 8. It doesn't really matter which one's which. What does matter though is you, instead of 9, use that 8 there. Grab your calculator and punch all that in. You got 60 times 22 times 8, and you end up with a volume of 10,560 feet cubed, because we're doing volume. Now, they didn't ask us to find the volume of the pool. They said how many gallons of water will you need to fill the pool, and they told us that 1 gallon of water fills up about 0.134 cubic feet. So all we're going to do is we're going to take this 10,560 cubic feet, and we're going to divide it by that 0.134, and that's going to tell us how many gallons of water we need. So you grab your calculator and you divide that, and remember, when you're dividing that, you should come up with a fairly big number. Your answer should get bigger. So we take 10,560 divided by 0.134, and we end up with, and I'm going to round it off to the nearest gallon, so 78,806 gallons. We're going to need about 78,806 gallons of water. All right, on the next one, they're talking about a tree. This is my tree. I know most trees aren't this way, but we're just going to consider it like this to make it a little simpler, so we can get an estimate. We're not going to get an exact amount of the tree. You'd have to use a whole bunch of other formulas for that. They tell us the circumference of the tree is 7 feet. I think that's what they said. Yeah, circumference is about 7 feet, and the height of the tree is about 42, and we're not taking in consideration any of the branches or anything. So what we actually have is sort of a cylinder. No, it's not exactly a cylinder, but just to get an estimate of how much wood we're going to get out of this tree, that's what we're going to use. When we look at this, we need the height and radius. Well, we know the height. The height is right here. That's the 42. The radius we can get from this, the circumference. Remember, circumference of a circle should equal pi times diameter. So they're telling us that the circumference is 7. And what we can do is we can figure out the diameter by dividing this by pi. So just grab your calculator and you take 7 divided by pi, and you end up with diameter equals about 2.2, we'll say. We don't want the diameter, we want the radius. So to find the radius, we just split that in half, and that's going to be about 1.1. So the radius of the tree is about 1.1 feet. And again, since we're estimating, we're not worried about how many inches that is or anything else. So we're going to put in here pi times the radius, which is 1.1 squared, times the height, which is 42. Grab your calculator and punch all that in. When I punch it all into the calculator, I end up with about 159.7, and our units, since we're dealing with volume, are feet cubed. So we can expect to get about almost 160 cubic feet of wood out of that tree. Just one other thing I wanted to go over real quick. If you, on your formulas worksheet, I just wanted to go down through a few of the formulas to make sure that you remember on some of them. Remember, for kite and rhombus, the D1 and the D2 is a diagonal. Remember, for a rhombus, you can also use the parallelogram formula because a rhombus is a parallelogram. For circles and ellipses, the R's are for radius. Just going through some of these terms to make sure you remember them. On a lot of the stuff, you'll see a S. That S is the length of a side. If it's a 2D shape, it's a two-dimensional shape, that's just the length of a side. But then you get the S's on some of the three-dimensional, and that's the slant height. That's the slant height. The slant height. So don't get the S's for two-dimensional and the S's for the three-dimensional shapes confused. H is the height, and that works for two-dimensional and three-dimensional. Remember, on your three-dimensional stuff for S and H, if we're doing, like, let's say a cone, if we have this cone, that's the S, and then the slant height is the one that comes right down through the middle, like you were dropping a rope straight down to the base. That's your height. So this is slant height, this is regular height. Then the last thing, don't forget that the big B stands for area of the base of a 3D shape of whatever. So the base is always going to be an actual, like a circle or a square or a rectangle. So you have to find that. That's what the big B stands for in all the formulas. Hopefully that'll help some.